Hello and welcome to our second video for trig operations. I decided to make another video just because there are some fraction things that maybe we have forgotten about that I figured might take a little bit longer to explain. So here, if we want to add or subtract, we need to have common denominators. Now, how do you find common denominators? Well, with these trig functions, the easiest thing would be just to multiply one fraction, top and bottom, by the denominator of the other. For example, if I was adding 1/3 plus 1/2, I would want to multiply this 1/3 times 2/2 to give me 2/6, and then I would want to multiply this 1/2 by 3/3 to give me 3/6. And then I can combine those, 2 plus 3/6. We're going to do the same thing with trig functions. I have sine of x as the denominator here, so I'm going to multiply by sine of x and sine of x. And if I do that, we'll go a little bit at a time. So if I do that, I would have sine of x times sine of x on the top. I get sine squared of x over, I'm going to leave it for right now as sine of x times 1 plus cosine of x. If I look at my second fraction, I have a denominator of 1 plus cosine of x. So I'm going to multiply the top and the bottom times 1 plus cosine of x. Now this one we do have to do some FOILing because we have two binomials that we're multiplying. So I get 1 times 1 is 1. 1 times cosine is cosine of x. Cosine of x times 1 is cosine of x again. And then cosine times cosine is cosine squared of x. And then we're still dividing by sine of x times 1 plus cosine of x. Now from here, you don't have to necessarily show all of this work, but I'm going to do a couple things. I can see that my numerator is all in terms of cosine, except for this sine of squared of x. So I can write them all as one numerator together, but I do need to make sure that I want to change that sine squared of x into 1 minus cosine squared of x using my identity. So in that first fraction, instead of sine squared of x, I'm going to do 1 minus cosine squared of x. And then in my second fraction, I have these two cosine of x's here. Those I can add together. So I have plus 1 and then plus 2 cosine of x plus cosine squared of x. And again, now, when they have the same denominator, we can now make it all one fraction. All right, you might be able to see that if I keep simplifying this numerator here, I have a minus cosine squared of x and a plus cosine squared of x. So those will cancel. And I can also combine this 1 plus 1. So what I really have in the top is 2 plus this 2 cosine of x is left over. Divided by sine of x times 1 plus cosine of x, that denominator stayed the same. Now, if we can, we want to try and cancel things out if possible. And honestly, you might be asking yourself, like, how would I know what to do? And sometimes it is trial and error and just seeing what works. But on the top, we talked about GCFs in the last video. I can see that in the top, I can take out a 2 from both of my terms in my numerator. So if I take out 2, I'm left with 1 plus cosine of x. And my denominator has not changed yet. And now finally, when you have an entire factor, so I have 1 plus cosine of x on the top, and I have 1 plus cosine of x on the bottom, those cancel. And it's because you have that same factor on the top and the bottom. So what I'm left with is 2 over sine of x. Now you can choose to leave your answer like that because I do have it down to one trig function. Or if you want to write it as 2 cosecant of x, that works as well, because that would just be the reciprocal of 1 over sine. I have another one for you, and I will walk through this one. If you would like to try it on your own first, you can, and pause the video, but I am going to walk through this one as well. So if you want to try it out first, go ahead, pause it, and then unpause when you're ready to see the answer. Looking at my fractions here, I am going to multiply the first fraction by the denominator of the second. So times 1 minus sine of theta times 1 minus sine of theta. That gives me on top, well, I'm just multiplying by 1, so 1 minus sine of theta over 1 plus sine of theta, 1 minus sine of theta. I'm actually going to do that first. And again, a lot of times when you see these reciprocals, you do want to multiply them out, or not reciprocals, excuse me, conjugates. You want to multiply them out, and you'll see why, because usually we do this for a reason so that we can simplify my trig ratio. If I multiply these out, I would get 1 minus sine theta plus sine theta minus sine squared theta. This minus sine theta plus sine theta cancel, and I'm left with 1 minus sine squared of theta. So that is what's going to go in my denominator. If I look at the second one now, I want to multiply top and bottom by 1 plus sine theta. And you'll notice you should get the same denominator. So I would have 1 plus sine of theta on top, because we're just multiplying by 1, and then over 1 minus sine squared theta. Now you don't have to show this next step, but I just want to show you when we do that, you can go ahead and put them all in one fraction if you want right away. I don't technically need to show that above step. If you want to go right into this red step, that's fine, because the goal is to make it one fraction. So now that I just combined everything together. When we add things with common denominators, you can combine the numerators and the denominator just stays the same. And now I can look at simplifying. So I have, let's see, this minus sine theta plus sine theta, those cancel. And I'm left with, I can add 1 plus 1 over 1 minus sine squared theta. And I guess I'm just going to make 1 plus 1 too. Now, we don't want this because I have that 1 minus sine squared theta. That is a trig identity, and we do want to use that Pythagorean identity if I can. 1 minus sine squared of theta is cosine squared of theta. So now this, it would be the simplest form, or if you do, we could also write this as 2 secant squared of theta as well. So I will accept either of those answers. The last thing that I want to talk about is just getting a trig expression out of its fractional form. And this, we do something similar to what we just did actually on the last slide, where you want to multiply by the conjugate. As we saw, if I go back here for a second, when I multiplied a 1 plus sign and a 1 minus sign, I was able to write that as cosine squared. Because what you'll see is when you have that plus minus, these middle two terms will cancel. And then we happen to be left with the trig identity. So that's what your goal is to try and solve for. So that's what we're going to do here, is we are going to multiply by that conjugate. So if I have 1 minus sine of z, I'm going to multiply by 1 plus sine of z on the top and the bottom. And when I do that again, I'm multiplying by 1, so my top is just going to stay 1 plus sine of z. And the bottom, I'm not going to go through and do all of that work, but we saw that when we multiply out that bottom, we got 1 minus sine squared of z. And again, you can go back in the video to see where that math was, but it's exactly what we did here when I did 1 plus sine, 1 minus sine. I'm going to do what I did before and use my Pythagorean identity, and I'm going to rewrite 1 minus sine of z as cosine squared of z. Now, why do I like to do that? Well, a rule of fractions, if I have x plus 1 over 2, if I have two things in my numerator and one denominator, I can split those up into two separate fractions. And that's what we want to do here to simplify it down. So I can rewrite my two fractions. One would be 1 over cosine squared of z, and my second one would be sine of z. Make sure you don't forget that plus in between. Sine of z over cosine squared of z. And then from there, we can simplify. So what is 1 over cosine squared of z? That is secant squared of z, using that reciprocal identity. I can rewrite sine of z, so I'm going to split up my cosines here. So with my fractions, all I did was I just split up cosine in the denominator into two things. I can write this one now, sine of z over cosine. So what is sine of z over cosine of z? Well, I still have this secant squared of z. And then sine of z over cosine, that's tangent of z. And then what is 1 over cosine? That is secant of z. Now you might ask yourself, like, how would I know to do all of that? Well, we want to get it out of its fractional form, meaning I don't want any fractions left. And so this allowed me to make that happen. Again, a lot of this comes with practice. So if you can remember that first step of multiplying by that conjugate, that will be helpful. And then after that, it's just a matter of playing around with the simplification. One final example for you to try. Again, if you want to go ahead and pause the video, if you want to try it on your own first, go ahead. Otherwise, I'm going to walk through this final one as well, and then that will be it for today. So we want to get out of its fractional form, which means I'm going to multiply by the conjugate. So I'm going to multiply times 1 minus sine of x. On the top, I'm going to distribute. Now, you might be able to simplify this without distributing. I personally just like to, so it's just a personal preference, but you might be able to simplify it without distributing and keeping those separate. But I'm going to multiply cosine squared of x to both the 1 and the minus sine of x. And then on the bottom, we've seen this a couple times now. 1 plus sine of x times 1 minus sine of x is 1 minus sine squared of x. And again, why do we like that? Well, because now that 1 minus sine squared of x is cosine squared of x. So I do like seeing those two steps just to show that, like, when you multiply it, you get 1 minus sine squared, but now I have that identity to be cosine squared. We can do what we did before, simplify my fractions. So I have cosine squared of x over cosine squared of x, taking this first term in my numerator. And then minus, now I can take my second term, and again, be careful, it is minus, so don't forget that minus. Cosine squared of x times sine of x over cosine squared of x. And now I can simplify cosine squared over cosine squared, that's 1. And then minus, these cosine squared of x's cancel, leaving me with just sine of x. I got rid of my fractions, so that is my final answer. And that is how you get rid of a fraction.